The electromagnetic spectrum. What is it? Where does it come from? What do we use it for? Let's talk about it. Your learning targets for this section are to be able to describe and rank different forms of electromagnetic radiation, including how they're used and hazards of each of those types of radiation. Also, you should be able to find and analyze the patterns in the electromagnetic spectrum based on things like wavelength, frequency, speed, and energy. The electromagnetic spectrum is the range of all of the types of electromagnetic radiation or electromagnetic energy. That energy is the full range of frequencies that characterize light. When we say it's characterizes light, that's because this electromagnetic energy comes from things like the sun. So those frequencies can be things from radio waves to gamma rays. The energy that's emitted is massless particles. So there's a stream of radiation that's being emitted, and that's our electromagnetic radiation. Electromagnetic radiation or energy travels in the form of waves. So before we talk about what those types of energies are, let's talk about waves. Now, first thing, when we talk about waves, we talk about their wavelength, which is really the length of one wave. So that could be from crest to crest, trough to trough, or from one node all the way through one cycle to the next. All right, we also talk about amplitude, which is the height of the wave, and we talk about frequency. So frequency is how many waves pass by a specific point, usually in a second or per some amount of time. So a high frequency wave has a much shorter wavelength. A lower frequency wave has a longer wavelength. These have lower frequency, usually have lower energy. High frequency are higher energy waves. So, of course, there's calculations that go with this. We're not going to worry too much about the calculations, but you need to understand the relationship between frequency and wavelength. So to do that, we're going to look at the symbol for frequency is F, the symbol for wavelength is lambda, and then C is the speed of light. I'm showing you that because you need to understand this equation and just really the relationship, not how to use it. C is the speed of light. All light travels at 3 times 10 to the 8th meters per second. So that's a constant. C is the ultimate constant. Now, lambda is wavelength and frequency is F. So if it's lambda times F, it's wavelength times frequency gives us the speed of light. Now what you'll notice here is that we have to multiply these two numbers to always get 3 times 10 to the 8th meters per second. So if our frequency increases, that means our wavelength decreases. And if our frequency decreases, then our wavelength will increase. Remember, higher frequency means a higher energy wave. So the types of electromagnetic radiation, remember we mentioned go from radio waves to gamma. Well, everything in between is included on this diagram right here. So after radio waves, we have microwaves, then infrared, visible light, ultraviolet, X-rays, and gamma rays. Now remember, we just talked about waves, and we said the higher or the longer the wavelength, the lower the frequency. So that would be these down here. Longer wavelength, lower frequency, and lower frequency means lower energy. High frequency means high energy. So our gamma rays are the highest energy electromagnetic radiation that we have coming from the sun. A couple things I want to point out on this diagram. This penetrates the Earth's atmosphere. That's important for you to understand because that'll come in handy when we're talking about the types of radiation that can go through the Earth's atmosphere and then can harm us here on Earth, or the kinds of things that we can use to look out into space. Also, I want to point out the size that's on here. It shows you the size of each of these radio waves, or each of these types of waves. If you look at radio waves, they're about the size of a building. They can even be as long as mountains. Where you look at like X-rays and gamma rays, those are about the size, wavelength size of an atom, or the nucleus of an atom, which is tiny. Now that we know the types of electromagnetic radiation, let's look at what those different wave types are used for. First, we have radio waves. Most of us realize that radio waves are what we use for communication, listening to music, things like that. There's AM and FM radio, there's amateur radio where they, talk back and forth, things like that. Aircraft communications in there as well. When we get down to microwaves, most of us are familiar with a microwave oven. That's used for cooking. Microwaves are also used for transmitting signals for communication, cell phones, things like that. Also, microwaves are used to monitor rain and things in the weather. One of the problems with microwaves is that it can heat body tissues and things like that, so you have to be careful with microwaves and exposure to that. Infrared radiation is used for optical fiber communication. We use it to map dust between stars out in space. It's used for remote controls on TVs. We use it with night vision goggles, things like that. Infrared radiation can burn your skin because it's actually felt as heat. And we have visible light, which is red, orange, yellow, green, blue, indigo, and violet. Those are the colors, ROGBIV. And that's obviously used to help us see. Ultraviolet light is just beyond the violet spectrum. That is ultraviolet light from the sun. This can be used for detecting forged money. It's used to sterilize things in hospitals. UV light can cause cancer, so that's one of the hazards. Then we have X-rays. X-rays are what we use in like airport security, or going to the dentist or the doctor to get your teeth X-rayed or bones X-rayed and things like that. Some of the hazards with X-rays is they can cause damage to cells, and those damages can cause mutations in the cells, and that can lead to cancer and death of the cells in your body. Gamma rays are used to kill cancer cells, and they also allow doctors to see inside your body with different technology like PET scans, things like that. These can also damage cells in your body, which can cause mutations that lead to cancer and death. So it's important, gamma rays can help you kill cancer cells, but they can also cause cancer. So it's important to be limit exposure to these things. Now that you've finished this podcast, you should write 2 short paragraphs. One, to summarize the types of electromagnetic radiation, what they're used for, and hazards. And another paragraph that explains how energy, wavelength, and frequency change as you move from one end of the electromagnetic spectrum to the other. So as you go from radio waves through all of the others to gamma rays, or the other direction.